Welcome back to Hidden in the Stars. Humans have long used the sun, moon, and stars for navigation purposes. But what about animals? How dependent are they on planetary bodies for movement? The answer may surprise you. Children are taught in elementary school about animals who are nocturnal as opposed to diurnal, active during the day, i.e., most humans, and crepuscular, active at dawn and dusk. While each of these circadian adaptations serves a specific purpose, let's look for a moment at nocturnal animals. Scientists have proven that nocturnal animals benefit from reduced competition and fewer predators. Additionally, in warmer climates, animals can avoid heat exhaustion by foraging or hunting at night as temperatures drop. One of the more well known nocturnal animals is the owl, for instance. Aside from their visible physical adaptations, such as large eyes for increased nocturnal vision and soft rather than stiff feathers, enabling nearly silent flight, there are other behavioral adaptations that are not as easy to see. Hunting rabbits by the light of a full moon is one thing, but how do owls hunt on cloudy, low light nights? For that matter, how do migratory birds know where to go and where to return? The answer lies partly in stellar orientation, or the use of stars for navigation by determining direction and location. Scientists found that migratory songbirds use the rising and setting sun as an east west axis, but were convinced that there was more to the story than the position of the sun. Researchers at Lund University in Sweden discovered that the compass system of migratory birds was complex and involved many factors. According to their research, quote, birds recalibrate their magnetic compass by sunrise sunset polarized light cues, provided they have access to the vertically aligned band of maximum polarization near the horizon and a view of landmarks. Once the stars appear in the sky, the birds then recalibrate the star compass with respect to the recalibrated magnetic compass. The birds, therefore, use the Earth's magnetic field to calibrate their position in combination with position of the stars. Research has shown that, in controlled settings, some bird species use stellar orientation in the absence of magnetic cues, ignore conflicting magnetic cues when observing a clear starry sky, and some may even recalibrate their magnetic compass to agree with conflicting stellar cues. We'll leave the links to the studies in the description box for those viewers who wish to dive deeper. This system of navigation is not unique to avian species either. Other animals known to use stellar orientation include beetles and seals. Interestingly, one species of nocturnal beetle uses the entire Milky Way to orient rather than a single star. The seals were tested for their use of stellar navigation in a planetarium. According to an article in BBC Sky at Night magazine, quote, in an experiment, 2 harbor seals were placed in a 5-meter round pool beneath a dome simulating the northern hemisphere's night sky. Researchers used a laser pointer to highlight a star, training the seals to swim towards it for a reward. Later, they changed the dome's orientation and removed the laser, yet the seals still swam toward the correct star. This suggests harbor seals naturally recognize star patterns and may use celestial navigation in the wild. One problem for animals who navigate by moon or starlight, then, is light pollution, which can have devastating effects on animal populations. Artificial light can cause migrating birds to go off course and to misread seasonal cues, causing them to leave too early or too late. Frogs and toads rely on nighttime croaking to attract mates. Artificial lights have interfered with breeding habits, with reduced populations as a result. Sea turtles hatch at night, an adaptation that allows them some degree of stealth to avoid predators as they cross the beach to return to the ocean. They navigate by following the light of the moon to reach the water. In nesting sites with light pollution, however, the baby sea turtles are moving toward the artificial lights and away from the beach, causing hundreds of millions to be lost each year. There is some good news, however. According to an article by the National Wildlife Fund, quote, Members of the Ventura Audubon Society approached the operators of a power plant about an hour north of Los Angeles. Its location, an otherwise undeveloped stretch of sandy beach, is a habitat that has become as rare as it is crucial for California shorebirds such as the threatened western snowy plover. For more than a decade, the Society had been counting 20 or more plover nests each year to the north and south of the generating station. But the birds never nested on the half mile of sand directly in front of the plant, and the conservationists suspected the facility's bright security lights might be the problem. Plovers need darkness to hide their open sand nests from nighttime predators. The plant managers agreed to dim the lights, and the following year, in 2013, 10 snowy plover nests appeared on the previously barren beachfront. Curiously, animals are not just relying on the position of astronomical bodies for movement. While the full moon may not cause humans to turn into werewolves, it can affect animal behavior. Lions, who normally hunt at night, have been observed to hunt less during the full moon and instead seek out prey the next day. European badgers raise their legs up to pee more during a new moon than a full moon, which seems harmless enough until the reduced scent starts to affect their mating behaviors. Even zooplankton shows some effect, changing from a standard 24-hour circadian rhythm to a 24.8-hour lunar day during the winter months. But perhaps the most unexpected connection between astronomical events and animal behavior appears in whales. Astrobiologists have been studying a possible correlation between geomagnetic solar storms and mass whale strandings for years, with mixed results. According to an article in the International Journal of Astrobiology, quote, support for a causal relationship between cetacean strandings and geomagnetic storms ranges from long-term statistical correlations with solar activity to documented coincidences for single events. The article goes on to observe that weaker solar storms can more strongly affect whale navigation than strong storms, with the researchers suggesting that the animals more quickly recognize errors in magnetic navigation in the stronger storms. Scientists are still in debate regarding this issue, with a more recent study stating, quote, no statistical associations are found in 30-day or shorter timescales that are believed to be relevant for possible animal response to changes in geomagnetic conditions. If geomagnetic activity plays any role in fresh mass strandings analyzed in this investigation, the connection has to be very subtle and likely coupled with a complex combination of multiple environmental factors. So, what do you think? Which animal behavior surprised you the most? As always, we're looking forward to reading your thoughts in the comments section. Do you have a topic that you would like us to discuss? Be sure to let us know. Catch you next time on Hidden in the Stars.